Okay, good. Good afternoon, everyone. I'll talk about IETF, give you a reason to find the IETF important. How many of you have been to an IETF meeting here? How many have heard about the IETF, at least? This will be easy. Okay. So, what is the Internet Society? We are a course-based organization. Our mission is that, to promote the internet, and our vision is that the internet should be for everyone. We have a global presence. We have chapters all over Africa, all over the world, and there's a map there with some of the areas where we have chapters. So I'll move on and talk about internet standards. So a few of those acronyms should look familiar to most of you in the room, isn't it? I'm hoping so. Yeah, I'm sure you can find one that you can explain a bit. All these standards, all these acronyms have a very important meaning. They are the backbone or the building blocks as to how devices on the internet communicate and are able to reach each other. And all these standards were developed by the IETF. So, what's the IETF? It's a large, open, international organization or community of network designers. Research goes on regarding how to make the internet better. Actual work of the IETF is done in working groups. I'm going to come to that next. But the main goal of the IETF is to make the internet better. So, IETF has 3 meetings every year. Participation is open to everyone. Those are images from past IETF meetings. The main tenets of the IETF is technical competence, rough consensus, meaning a large majority of the people who are involved in certain work should agree that that's the best way forward with the work. And it's a volunteer call. There's no, like monetary gain in terms of working in the IETF or producing a standard. So there's a lot going on in the IETF. There are areas and there are lots of working groups all dealing with different topics, but you can sort of categorize the work into 3 main areas. There's the IoT, or the Internet of Things. As we all know about the IoT, it's going to be about all these small devices or distributed devices sending information and all that over the internet. Security and privacy, making the internet more secure, more trustworthy so that we can use it for doing our day-to-day activities. And also real-time communication, how we can use the internet to make live video, chat, calls, and so on. So this is a very coarse diagram of how the IETF works. There are 7 areas. Work is categorized into 7 areas. There's an internet area that deals with work around IPv4, IPv6. There is a routing area that talks about BGP or SPF. That's where you find working groups related to that type of area. So that diagram, what it's trying to show is at the top, the 7 areas, and then below that, we have working groups. And each area has a different number of working groups. Each area is led by an area director. Sometimes acronyms are just called an AD. And there's a URL there that I've included there with more information about the IETF. I'll just give a bit of information and guides on how to do it. So IETF working groups consist of several individuals working together to produce an RFC. An RFC is a document that contains a guide as to how software should work on the internet, how a device should communicate on the internet. It's a document that's produced mostly by working groups, but also as an individual you can submit work and it's accepted as an RFC. Working groups are typically created to address a problem, and the scope of what the working group is trying to do is defined in something called a charter. And working groups are usually short-lived. So for example, a working group will be formed to fix something in BGP. Once that problem is solved, that's the end of the existence of that working group. And decisions are made through rough consensus, meaning that a very large majority of those who care need to agree. And I'll try and demonstrate that with your help next. So it's not easy to talk about the IETF. It's usually better to demonstrate. As ISOC in the Africa Regional Bureau, we've been talking about the IETF for many years and not gotten a lot of traction. So we decided to change things up and try to do a bit of hands-on activities we'll talk about. So I'd like to give an example about IoT work going on at the IETF. Suspend your disbelief a bit and just try and imagine that all this is work that's happening and is about to take place. So Intelligent transportation systems. So there is a working group on the IETF that is looking at how IP can be used in vehicles, in cars, in bikes, in buses, and so on. What that means is your vehicle, if you're on the road, can communicate with the next vehicle, whether it's a bus or another car or a motorbike, and share information about speed, about direction, about stopping, and so on. Also, your vehicle will be able to communicate with infrastructure. So, for example, if you arrive at a shopping mall or something and you need to identify a parking slot, maybe your vehicle will communicate with the infrastructure there and get information as to where the free parking slot would be. So simply put, vehicles could use IP to communicate with each other, to relay information about speed, direction, and so on. And this could help potentially, make driving much more efficient, much more safer. So for example, if your car communicates to my car that you're slowing down, my vehicle will make a decision to slow down as well and avoid an accident. So this is actually a real working group at the IETF. So use cases. Sorry if that diagram is not very clear, but there's a vehicle at the front and there's a vehicle at the back. The vehicle at the front asks the vehicle, the vehicle behind it asks the vehicle in front, what's your IP address? And the front vehicle replies and says, this is my IP address. And then the vehicle at the back asks, what's your speed? What's your heading? And so the conversation goes on. And at the very end, you can see the vehicle at the back asks, can I follow you? And then the vehicle at the front can decide and say, I can say yes, you can follow me, or give you another answer and say no. Okay? That's just one use case. So, IP wave, IP wireless access in vehicular environments, IP wave. That's the working group I'm talking about. If you go to that URL, you'll see the charter. The charter, I said, just defines the scope. And you'll see that this group will work on vehicle-to-vehicle communication and vehicle-to-infrastructure use cases where IP is well suited to providing a communication, way for vehicles to talk over IP. These vehicle networks are characterized by dynamically changing network topologies and connectivity. Okay, you can go to that URL and see more. So it's very obvious that for this to work, the vehicles on the road would need an IP address. Is that correct? Do we agree on that? Yeah? You need an IP address. So what this working group did is they went out and did a survey to find out what are the current ways that could be used possibly to assign vehicles that are traveling on a road IP addresses. So for the purposes of this, presentation, let's assume that we are driving from here to Cape Town, okay? So one proposed way that's been identified, this came from the IEEE. It's called routing and address assignment using lane position information. So there's a group, there's a gentleman called Kato and et al., so with others. They've proposed an IPv6 addressment scheme that uses lane information. What does that mean? It means that if in this room we have 3 lanes, depending on which lane your car ends up in, you'd get an IP address with a certain prefix based on your lane. Okay? So just hold on to that memory as we go to the next one. So when it moves in a lane on a road segment, a vehicle auto-configures its IPv6 address with its MAC address and prefix assigned to the lane. So each lane would have its own V6 prefix. So that's one idea of how to get IP addresses to the cars. Here's another idea. Automatic IP address configuration in VANET. VANET meaning Vehicular Ad Hoc Network. And in this idea, this is an idea that's been proposed, a car would get an IP address based on a certain election. What would that election be? The vehicles on this road would decide, okay, there are 15 cars on this lane, and the vehicle at the front will be the new DHCP V6 server and give all of us IP addresses. We okay? Yeah? So let's assume there are others that have been proposed. I'm sure if you go to that document you can see, but for the purposes of thinking this through, what would be the best way to assign V6? And there's no wrong answer here, it's just an opinion. Maybe by a show of hands, how many think the best way to assign IP addresses on the road would be based on the lane you are on? Just by a show of hands. Not many people. Okay, how many people think the best way to get an IP address would be the cars to have their own mini election there and decide who's going to be the DHCP server for the rest of the way? By show of hands.
Humming.
Sorry?
They should hum.
Oh yeah, humming is the best way. So, rough consensus, the IETF is determined by humming. So let's try, just hum if you think you like the first one, whereby an IPv6 address will be assigned based on the lane you're driving on. You can just hum. Okay. And how many think the best way to get an IP address would be for the vehicles there to have a small election and determine who's going to be the DHCP v6 server there? I can't tell, mostly 50-50, okay? Somebody saying no to both of them. Okay, fine. Okay, so let's assume that, the best one is determined and it's, one of the ways to assign an IP address has been selected. What would be some of the use cases for vehicles to have V6 and having, communication along the way on a road? So there's RFC 8148. You can just Google RFC 8148. It's a document that describes how to use IP-based emergency services mechanisms to support next generation emergency calls placed by vehicles automatically in the event of a crash. So what that means is, in the future, maybe 5, 10, 15 years from now, when manufacturers are producing these cars that communicate with IPv6, you can make your vehicle can make an emergency call over IP, yeah, and alert whoever needs to be alerted about your accident, okay? And the migration of emergency calls to IP, that's just more information about RFC 8148. So, this is sort of newish work on the IETF. There's a lot of old stuff that goes on, or stuff that's started before. But I wanted to give this example to show you the type of timelines this could be in. If in the next, maybe, 5 to 15 years, manufacturers decide, okay, there's a lot of value in manufacturing cars that can communicate over IPv4 and IPv6, what would it mean for a vehicle manufacturer? What would that mean? What could be the reason for them to move to V6? Well, what if it is proven that, and yesterday I was listening to a presentation by Dr. K, I think it was, that it is safer and more efficient to use cars that communicate using this telecommunication infrastructure. That could be a good use case, yeah? What would it mean for the ISP? And I know for ISPs here, we have a number of ISPs. What would it mean if, cars now need to get IP addresses on the road? What would it mean for you as an ISP, for the ISPs that are in the room? Sorry? More money maybe? A new customer? Yeah? All these cars will need IPs, so someone has to give them IPs, isn't it? Yeah? Probably more investment on infrastructure in terms of Wi-Fi or LTE or whatever is going to be on the roads. What would it mean for a content provider? You now have access to push data to a new customer, more or less, who's mobile. What would it mean for them? Any ideas? Someone's coming to the mic. Okay, let's see.
Hello, Jan George.
Okay.
You asked before if we like first or the second way of assigning IP. I don't like neither of them. Why don't we just connect the car over some mobile network to have the internet connectivity, assign a car a /64 or even /56, so you can put IPv6 address on every sensor, on everything in the car, and then start communicating. And if my car is close enough to your car that they can talk directly and connect over the wireless, we have routing protocols that can announce my space to you or announce the space of my colleague that is behind me, to you, so you can talk, even if we are connected to different ISPs, we can then talk directly. These things have been already invented. Why reinventing the wheel?
So this was just a survey that they put out to determine. So I was just putting it here as a use case to get people seeing what the IETF work is like. Yes.
Rather tongue-in-cheek, what does it mean for me?
Yes.
Pop-up advert, no, as a driver, pop-up adverts on my heads-up display, no thanks.
So what he's saying is, as a driver, you could get custom adverts based on where you're traveling. Is that right? Yeah. So the implications of all this work that's going on at the IETF is that in the next, couple of years, you might need to make a decision as to whether you're going to get a vehicle that has all this capability. There are going to be advantages and disadvantages to it. They're going to be, it's going to touch on many people. It's going to touch on government. So for example, as a government, who's going to store all this information about where your vehicle is located, where your speed has been, who's going to be able to, analyze all this information and in a way, make sure that vehicles are able to, choose the best routes or choose the best ways to get to the other side of the road and so on, or to get to another side of the city and so on. For road safety, it might mean that vehicles are safer to use. Yeah, if your vehicle can inform my vehicle that you're slowing down or you're changing lanes and so on, you might be able to make the road safer for everyone, not only for other drivers but also for pedestrians. Going back to governments, there's a lot of use cases for this. They might want to regulate what type of information the vehicle can share. So, for example, would it be safe for all these vehicles to be IPv6 capable, and someone else from across the world can hack into them and disable the brakes or disable some other activity or disable something in the car? Okay, so that was just to get your heads thinking about what possible scenarios could be in for this type of example for IPv6 and the work going on at the IETF. You can go to that mailing list and you can see more about the work that's going on. So Africa and the IETF. So participation and awareness is low. I think I did a show of hands of how many people have been to an IETF meeting. Our engineers are not playing a big enough role. And what that means is products are being designed for us to be used by us. So for example, just that example of the cars, in the next 5, 10, 15 years, these cars might be coming onto our roads, okay? And they're going to be having all this capability, all these features to communicate over IP and so on. And, people in this region didn't play a part in how that's determined. I can give you, for example, if an IP address is determined based on the lane you're on, I come from Kenya. We have cars called matatus. Who's heard about matatus before? Good. A matatu in 5 minutes will change lanes 15 times. And in those 15 times, it will get 15 different IP addresses, okay? So I can automatically see one way that wouldn't work. So what I'm trying to explain is if people in the region don't play a role in what's happening in the IETF, we might just have to land with devices and equipment that have already been designed for us and we just need to use them, which might not capture the reality on the ground for us. There are people in the region who are following the conversation as ISOC and also with other partners like Afrinic. We're trying to raise that awareness. Not a lot of research going on internet standards. We're trying to include academia as well, the entrants, to get more involved in IETF research. How can you participate? This is a question I'm often asked. How do I participate in the IETF? Well, one way is to go there, but it's not easy to go to these meetings. It's a lot of expense. There are no meetings in Africa yet. They're only in Europe and the US. But you can join a working group. Follow the work on the mailing list. I would say 80%, probably more of the work that goes on in the working group will be on a mailing list. For example, if the example I gave about the vehicles interests you, you can join the mailing list and see what's happening there. Join a newer one, join the recent ones, like this one. This is a good one. Some working groups have been there for a longer period of time. Before you can be able to participate, it means you need to do a lot of reading, a lot of research before you can actually contribute. So the newer ones are usually better. IETF viewing hubs, these are dependent on time zones. So we had 9 viewing hubs in Africa this year that were following the events in IETF 99 in Prague. Teaching IETF content universities, we have a bit of work going on with universities trying to help professors and teachers there come up with more IETF-related curriculum. That's work going on with someone called Dr. David Bekele, is the director for ISOC ARB, and he's trying to get that going in terms of advising how universities can involve more content. There's an interesting case study from Brazil, how they've decided to follow the work of the IETF. They have a steering committee that's called CGI.BR, and the mission is recommending standards of technical operational procedures, establishing directives related to use and development of the internet in Brazil. So they're sort of like a think tank and body that advises the government on IETF. So what they've decided to do is they set aside a small budget to send professors to each IETF meeting just to follow what's happening and advise the government as to what's happening and what would be key. So for example, this might be something that may interest the government in the next few years, vehicles coming with the ability to communicate over IP. I thought that was an interesting way to do it. Hackathons. So a hackathon is simply, sitting like this where we sit down and analyze the work of a working group and try to see if we can come up with running code. With Afrinic, we said, let's try one this year. So together with Afrinic, we sat down and decided how to do a 2-day hackathon. We did it during the Africa Internet Summit, which was in Nairobi. We had about 40 participants, mostly from research education networks and universities, just to sit down, try and solve a problem that's going on in the IETF. And we had an expert on IPv6, his name is Fernando Gont. Then we had an expert on DNS called Joe Abley, and we had a local expert called Kodaren, and we just divided people into 3 groups, tried to get people thinking and working about, what's going in the IETF, try to solve a problem. And it went surprisingly well. And one of the working groups actually managed to recompile a kernel and make that operating system, which was FreeBSD, compliant with one of the newer, RFCs. And it was just to demonstrate, prove that this is something that actually can be done in the region. Now, we do have a mailing list. So we have a number of mailing lists in the region. As you know, there's AFNOG, African ones. There's a new one. It's just called IETF Africa. We try to keep the conversations related to IETF stuff. We give updates about IETF. We tell you about upcoming activities. And one of the activities we've planned before the end of the year is a webinar. We've planned 2 webinars, at least so far. One of them will actually be on vehicle-to-vehicle communication. There's a professor in Morocco who's working on this. He's going to give a 1-hour talk about the research that he's doing related to vehicle-to-vehicle communication. We're also going to have another webinar on it's called IDEAS, identity-based identity management of devices on the internet, such that how many of you are affected by the Dyn blast last year, the DDoS attack? How many of you are affected in one way? Who? Nishal, you're affected by everything. Okay, so what happened in Dyn last time was there was a huge denial of service attack that hit them, and most of the traffic came from cameras and printers, weird devices that shouldn't be sending that type of traffic. So there's a lady called Padma. She's from Mauritius, and she's trying to get it going as a working group, and I've put the link there. And it's an interesting idea of how to control traffic for devices based on the identity. So for example, this microphone that I'm using should not, if it was an IP-capable device, it shouldn't send ping packets. It shouldn't send DNS queries. It should just be, keeping traffic local within this LAN. So I thought that's a useful if it turns out to be a working group, it should be very interesting. So basically that's it. So I'd like to stop here because of time. I think I'm done. Thank you very much for your time. Okay.
Hi, Andrew here again. Kevin, I've got a couple of questions and a comment or two.
Yeah.
Look, the IETF, in my view, is a nice idea. But my problem here is that it's become a vendor's playground from everything that I can see. The vast majority of the RFCs that are coming out there, whose names are on them? Cisco, Juniper, Huawei, Facebook, Google, NTT, the big players.
Yep.
Is it in my case, as a large operator, with very deep ties inside those vendors, is it not more worth my time funneling what I want through a vendor in order to get more traction? Yes, I'm following the IETF. Obviously, I follow everything that comes out of there. But to push through my ideas, is it not going to get more traction in that fashion? Because I worry that there are things that at the moment the IETF seems very driven almost by commercial interest. If I look, we sat with, IPv6 has been around since 1995, 1996. LDP6 didn't see the light of day until a year or two ago. There's still SNMP standardized V6 MIBs. When that came up, for 4 years, people sat and said, well, there was no interest. It came from the vendors though, because there were people like me who were saying, you know? So where's the balance here? Where do I decide, talk to my vendors, and where do I actually try and fight what is going to be a years-long battle to try and get a voice in there? What's your view?
Okay, so that's a good question. Let me say this. You are in a privileged position as a big ISP in the region. So you have, you have the reach to talk to your vendors, whatever equipment vendor you're using to take your message to the IETF. That may work for you, but it's not probably something that would work for everyone, because it's not really that we have, ties to every, big vendor. So it's something that might work for you, but probably not for the larger community. Because, for example, if I want if I wanted my opinion pushed to a new standard, for example, and I don't have the reach of a big ISP in the region, the only way I can do that would be through the working groups. And actually, it's an interesting question, because when I get the chance to go to the IETF, the people I meet say we're not getting enough people from Africa participating, giving their input. And it's a bit of a chicken and egg problem, because they say they can't bring a meeting here because there's not a big enough audience at the moment. And we can't take a big audience there because it's very expensive to go to an IETF meeting. Yeah, so it's a bit of a chicken and egg. So my view is that the more people we get involved, the more people we get aware about what's going on the standard, what's going on in the IETF, the more involvement in the region we can get, and then the more voice we can get at the IETF as a community. Yeah. Next question.
Ben, work online. I'm actually addressing Andrew's question, if you don't mind. So the reason for me to be going to IETF meetings, not just relying on my vendors to do it for me, is that, and oftentimes the point you make is totally valid. For a lot of standards, the vendors know it needs to happen, their customers know it needs to happen, they'll just get it done. They have the commercial imperative to do it. But there are some efforts where there either isn't enough commercial pressure on the vendors to get it done because their customers aren't speaking up, or at least not the right segment of their customers are speaking up, or there are features that we're asking for that are commercially inconvenient for them. So anything that, for example, limits fib size sprawl, vendors don't love. They'd rather sell you a larger router. And if we want serious work to happen at the IETF on those kind of issues, it's operators that buy the equipment that need to deal with it, not people who are making money out of selling it.
Can I clap for him? Nishal, no hats, be short. That's going to be difficult. So I've been to a few IETF meetings, usually not by choice. It is one of the scariest places in the world. Really, because the meeting room has got like 150 Andrews in it. Not Andrew Owens. You guys know who I'm talking about. So in an environment like that, in such a hostile environment, why would I want to inflict let me pick on someone, why would I want to inflict him, someone I might like, and take him there to say, this is potentially a place where you can learn, contribute. Now, I understand you can't do anything about that, but what are you doing to soften the blow for newcomers? Now, you're talking about working with schools, you're talking about working with professors, you're talking about working with the young upcoming engineers. What are you doing with them to make it such that they don't go into a meeting and then run screaming out at 9:15 at the end of the first tea break?
Okay, so good question. 150 Andrews, 200 Nishals at the IETFs. Here's what we're doing. So I gave the example of the hackathon. Okay, so that was aimed at a newcomer who's interested in playing a role in the standards part but doesn't really know where to start, because you're right, it's a bit, if you don't know what you're doing at the IETF, it's probably not the best place, not the safest place for you to be. So we're trying to do the stuff like the hackathons. We're going to do a lot of the webinars. It's been work that we've been doing over the years, but we've now sort of found a formula we think that can scale. So on the mailing list, we're going to give more information, but it's going to be more stuff around hackathons, more webinars about what's going on at the IETF, specific topics. Another challenge for the African region, Africa is huge. So what's important in East Africa as a standard would probably not be important in West Africa. So identifying the topics that would interest a big community has also been a challenge. But we think we found a working formula. So please join the mailing list and there'll be more information there coming through. Thank you. Oh, last question.
Yes,
So,
last question. Amrish Frenik. I've been working with a few people from the community network community, the Gaia IETF working group. Yeah. And one of their main concern is that, they're already working with a lot of protocols, mesh protocols, for example, Batman or BMX, which they have been using for a long time. And that community thinks it is a standard, so it is being used as standard for them. Yeah. But it is not an IETF standard.
Yes.
But their concern is that bringing that standard to the IETF might actually kill the whole spirit of it. Yeah. So how can we actually address this type of concern?
Okay, good question. So let me answer very quickly. The BMX standard and the Batman standard for community wireless, we have been in touch with the guys who've done the code on that, and they want to make it an IETF standard. We are helping them to do it. And actually, one of the guys who came through the hackathon in Nairobi, he's a gentleman from Nigeria. He's helping them to put in the RFC documents, the draft documents together to make them as an RFC. So yeah, that's a valid question because it's a very unique standard. It sort of breaks a lot of the stuff we know about how devices should communicate. But we're in touch with myself and my colleague in Latin America. His name is Christian. We're in touch with them. We're trying to see if we can get that as a standard. Yeah. Thank you.
Okay. Thank you very much, George.